Hello everyone. Today we are going to discuss the topic of inorganic chemistry, that is lesson number 9, element of group 13, 14, 15, which belongs to inorganic chemistry. This is our lecture number 5. See here the objectives of lesson. First of all, we look the introduction of carbon family or group 14 elements in the periodic table. After we look the electronic configuration of group 14 elements. Then we look the abundance of carbon family. After we look the physical properties of group 14 elements. And the last point of this topic, we discuss the chemical properties of carbon family. Here, now we are going to introduce group 14 elements. Group 14 elements are also known as the carbon family. Carbon family starts from the carbon element and ends with the flerovium. Its chemical symbol is Fl and its atomic number, the flerovium, shows the 114 atomic number, means 114 the atomic number is, and the research is still going on the flerovium. So far no use of flerovium has come out of the research lab, and no any kind of application also comes from the research lab. So that's why the flerovium is not included in our syllabus. So we are going to study carbon family up to the lead. So see here, the first member of group 14 is carbon, silicon, then germanium, tin. The chemical symbol of tin is Sn. Next one, lead. The chemical symbol of lead is Pb. So these are the group 14 elements. These are the group 14 elements: carbon, silicon, germanium, tin and lead. So now where they are placed in the modern periodic table? This is our modern periodic table. Already we look in the group 13 elements about the modern periodic table, and already we look some information also about the periodic table. So now we know the p block elements start from the group 13 and ends with the group 18. So these are the p block elements, and these are the group 14 elements. So now we are interested in group 14 elements here, and see, this is our carbon family. Okay, so this carbon family is placed in group 14. ही carbon family group 14 मध्ये place केलेली आहे. So the carbon family is placed in group 14 in modern periodic table. Look here, the first member of group 14 is carbon, then silicon, germanium, tin, lead, and the last element of carbon family, that is flerovium, but it is not concluded in our syllabus till today because the research is going on the application of flerovium, and there are no uses has come out of the research lab of flerovium. So त्याचे काही uses पण अजून आले नाही, so it is not concluded in our syllabus. So we are going to study from carbon up to the lead. Okay, after we look the electronic configuration of group 14 elements. So first of all, carbon is there. Already we looked the sequence in the previous lecture. आपण डिटेल मध्ये बघितलं होतं. S orbital contains 2 electrons, p orbital contains 6 electrons. Maximum capacity of 6 electrons. So now here we look the electronic configuration. Carbon shows 6 electrons. So 1s2, 2s2, 2p2. Silicon shows 14 electrons. So 1s2, 2s2, 2p6, 3s2, 3p2. Germanium shows 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2 electrons. So according to the above principle, we fill the electrons. Okay, according to the sequence. आपण त्या sequence नुसार electrons fill up करतो. हे आपल्याला माहिती आहे, आपण previous lectures मध्ये बघितलं होतं. Tin. It shows the atomic number of tin is 50. 50. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 4d10, 5s2, 5p6, 5p2. Okay, so 5s2, 5p2 is the outermost electronic configuration of tin. Then lead, see the outermost electronic configuration, that is 6s2 6p2. So हे बघा इकडे लक्ष द्या, हे काय सांगताय, 2 means carbon present in second period, okay, 3 present, silicon present in third period, 4 represent germanium present in fourth period, and lead, it shows the 6, that means it is present in sixth period. So this is important part. Another part, तुम्ही लक्षात कसं ठेवणार atomic number? So it is very easy way. 6 plus 8, 14 electrons, 14 plus 18, 32 electrons, 18, 32 plus 18, 50 electrons, 50 plus 32, so there are 82 electrons. So in this way, जर तुम्हाला कार्बनचा atomic number माहिती असेल, so you can calculate the atomic number of other group members. So तुम्ही easily calculate करू शकता दुसऱ्या मेंबर्सचे, दुसऱ्या एलिमेंट्सचे atomic number. And already we know the Above principle. According to the Above principle, अपन sequence ने हे electrons fill up करतो. Now see, after that, tricks how to remember the group 14 elements. तुम्ही group 14 elements कसे लक्षात ठेवू शकतात बघा, सिंपल आहे. कहे सीता और गीता सुनो प्रभु, कहे फॉर कार्बन, सीता फॉर SI, गीता फॉर GE, सुनो फॉर टीन, प्रभु for PB. So this is the easy technique. So you can easily remember this group 14, Kahe Sita or Gita Suno Prabhu. Okay, so this is the simple technique to remember the group 14. Now next we look the representation, another representation of electronic configuration C. In the simple way, you can use the zero group elements. With the help of zero group elements, you can write down the easy electronic configuration. तुम्ही easily electronic configuration लिहू शकतात बघा. Carbon 6 He 2s2 2p2, silicon 14 Ne means 10 electrons 3s2 3p2, germanium 32 atomic number, argon 3d10 4s2 4p2, tin 50 atomic number, krypton means 36 4d10 5s2 5p2, lead atomic number 82, xenon means 54 plus 14 68 plus 10 78 and plus 4 82. So in this way तुम्ही simple way ने सुद्धा electronic configuration present करू शकतात. Remember it, लक्षात ठेवा. Next one, occurrence or the abundance of group 14 elements. First one, the group 14 elements in the earth crust. So silicon is most abundant in the carbon family. See the decreasing order. After silicon there is a carbon, tin, lead and germanium. Next one, the occurrence. Carbon exists in the elemental state as well as combined state also. Silicon exists as a silica and silicate form. The tin present in the tin stone and cassiterite, that is SnO2 form. Lead exists in a mineral like galena किंवा सर्क्यूसाइट मिनरल, that is lead carbonate. lead carbonate ला सेरुसाइट मिनरल असं म्हटलं जातं, लक्षात ठेवा. सेरुसाइट मिनरल, that is lead carbonate. Now here we discuss physical properties of group 14 elements. So first of all, we look the physical properties of group 13 elements in previous lecture also. So already we know the physical properties like atomic radius, atomic size and ionization enthalpy. So now here also we first look the atomic radius, that is the first physical property. So see here, atomic or ionic radius. So atomic or ionic radius increases from top to bottom, means from carbon to lead it is increases. And why it is increases? Because the new shells are added. So already we look in the previous lecture in the electronic configuration. So if you observe that, see here, suppose if we take the example carbon, atomic number carbon is 6. So see here, its outermost electronic configuration is 2s2 2p2, and silicon shows outermost electronic configuration, that is 3s2 3p2. So from the electronic configuration we can observe that the carbon shows 2s2 2p2, means carbon shows 2 shell, and the silicon shows the 3 shell, means 3s2 3p2. And as we move down from the carbon to lead, the shells are increases. So that's why the atomic radius, atomic size and atomic radius increases. So as we move down the group, atomic size increases with increasing atomic number. It is because of the addition of new shells. Already we look in the electronic configuration. Now we look the some values of group 14 elements of ionic radii. See here, carbon shows the atomic radii, that is 77 picometer. It shows very small atomic radii, see 77 picometer. Silicon shows 118, and the lead shows the 146 picometer atomic radii. So these are the atomic radii values. Now next property we look, that is ionization enthalpy. Already we discussed in the previous lectures. Ionization enthalpy means the energy required to remove the outermost cell electron. म्हणजे outermost cell मधल्या इलेक्ट्रॉनला रिमूव्ह करायला, किंवा जो इलेक्ट्रॉन लॉस होतो outermost cell मधून त्याला रिमूव्ह करायला जी एनर्जी लागते त्याला आयोनायझेशन एन्थॅल्पी असं म्हणतात. नाव ionization enthalpy and atomic radii or atomic radius, ionic radius, these are inversely proportional to each other. Both are opposite. So now ionization enthalpy values as we move down the group decreases with increasing atomic radii, because both are inversely proportional. So see here, from this value we can also, atomic radii values, we can also tells about the ionization enthalpy. Carbon shows small atomic radii, so that's why it shows high ionization enthalpy. तो जास्त ionization enthalpy दाखवतो. Why? Because the nucleus and outermost cell electron, they interact more because the distance is very less, means small atomic radii. So nucleus and outermost cell electrons shows the strong interaction, and that's why very high energy required to break the bonds or required to remove the electrons. So carbon shows high ionization enthalpy. As compared to carbon, other elements shows from carbon to lead, ionization enthalpy decreases because atomic radii increases. So if we take the example of lead shows 146 picometer atomic radii. So it shows high atomic radii in group 14 elements. So the nucleus and outermost cell electron distance is large, and that's why the electrons of in the valence cell are easily removed. So see here, and another important point, see outer electrons become more loosely held down the group. And next important point, that is the shielding effect or screening effect. Means what? The nucleus shield by inner shell electrons, or protect the inner nucleus, protect by the inner shell electrons from the outer nucleus, outer electrons or valence cell electrons. Valence cell electrons पासून न्यूक्लियसचं प्रोटेक्शन कोण करतं? इनर शेल इलेक्ट्रॉन्स करतात. अँड दॅट्स वाय द इनर शेल इलेक्ट्रॉन्स प्रोटेक्ट द न्यूक्लियस फ्रॉम द outer shell electrons, and that's why the nucleus can't interact with valence cell electrons, and that's why they are easily removable from their outermost cell. So in this way, shielding effect also affect on the ionization enthalpy values. Okay, so greater the shielding effect, easily remove the valence cell electrons. So now here first of all we take one example and we look the diagrammatically representation of ionization enthalpy, so you can get the idea about that. Now see here, suppose we take the example, आपण एक example घेतलं बघा. Carbon shows 4 bonds. Okay, this is one bond, this is another bond. Okay, because of 4 valency carbon forms 4 bond, so this is the E1. Okay, this is E2, this is E3, and this is E4. So the E1 shows less energy, E2 shows more energy, then E3 shows more energy than E1 and E2, and E4 shows, means the ionization enthalpy 4, means the energy required to break the 4 bond is more as compared to E3, E2 and E1. So why it happens? हे असं का होतं की E1 ला कमी एनर्जी लागते, नंतर E2 ला थोडी जास्त, E3 ला E1 आणि E2 पेक्षा जास्त, आणि E4 बॉन्ड शोज मोर एनर्जी टू ब्रेक द बॉन्ड, म्हणजे E4 बॉन्ड ब्रेक करायला एनर्जी जास्त लागते. सो वाय इट हॅपन्स, सी हियर वी लुक द डायग्रामॅटिकली. ओके, सो फर्स्ट ऑफ ऑल दिस इज ॲन ॲटम, हा एक ॲटम आहे. अँड सी हियर द इलेक्ट्रॉन अँड न्यूक्लियस डिस्टन्स जर आपण बघितलं तर इथे न्यूक्लियस आणि इलेक्ट्रॉनचं डिस्टन्स जास्त आहे. अँड आफ्टर द लॉस ऑफ इलेक्ट्रॉन, what happened in the first ionization enthalpy? See here, after the loss of electron forms in the first ionization enthalpy forms a monovalent cation. And now here if we look in the monovalent cation, if we look the distance between nucleus and electron is less than this one. See here, if we compare it, जर आपण कंपेअर केलं बघा, इथे हा इलेक्ट्रॉन आहे, या इलेक्ट्रॉन आणि न्यूक्लियसचं डिस्टन्स थोडं जास्त आहे, मीन्स more than this one, and it shows less distance. So here the nucleus and electrons shows more interaction, and that's why it requires the more energy to removal of outermost cell electron. Okay, so these things are depend on, means the ionization enthalpy within the molecule is depend on electron and nucleus distance and how they are interact. So see here, after we look the loss of electron, then there is a formation of, in ionization enthalpy second, there is a formation of divalent cation, and in that divalent cation, if we look the distance between, now if we compare, see here, if the electron is here, means in the ionization enthalpy first electron is here, in atom electron is here. Now if we compare the distance between, in the divalent cation, distance of a nucleus and electron is very closer, here distance is very less, means nearer as compared to in atom, and in atom the distance between nucleus and electron is very greater than any other ionization enthalpy. So because of these things, the nucleus and electron interaction, because of this the ionization enthalpy shows greater values, means E1 shows less value, then E2 shows more value, because of these things, because of the nucleus and electron interaction. That's why the ionization enthalpies are increases. So if we look the ionization enthalpy in increasing order, so this is the divalent cation. So now here if we look the ionization enthalpy increasing order, IE4 means the energy required for the break the 4 bond is greater than E3, then IE2, then IE1. So E4 bond shows the more ionization enthalpy. So this is the ionization enthalpy. Now see the ionization enthalpy. Ionization enthalpy is decreases from carbon to lead, but here see the carbon to tin, it is marginally decreases, the decrease होते हैं. Okay, but the lead it is increased. Why? It is because of the, हे कशामुळे, because of the screening or shielding effect. हे screening आणि shielding effect मुळे असं होतं. There is a poor screening and shielding effect. That's why the lead मधले जे काही outermost electrons आहेत किंवा last electrons आहेत त्यांचं आणि न्यूक्लियसचं इंटरॅक्शन जास्त होतं. So energy required to remove that electron is more, म्हणजे इथे एनर्जी जास्त लागेल. ओके, बाकी मग टीनपेक्षा इथे जास्त लागेल, ते डिक्रीजिंग मॅनरमध्ये पाहिजे होतं, पण इथे तसं होत नाही आहे. इट इज बिकॉज ऑफ इथे 715 लागते आणि टीनला 708 लागते. 708 for tin and 715 for lead. इट इज इंक्रीज बिकॉज ऑफ द स्क्रीनिंग इफेक्ट. पण ती डिक्रीज व्हायला पाहिजे होती पण तिथे इंक्रीज दिसतंय. इट इज बिकॉज ऑफ द पुअर शेल्डिंग इफेक्ट. हे पुअर शेल्डिंग इफेक्ट म्हणून होतं. ऑलरेडी वी डिस्कस इन द प्रिव्हियस लेक्चर. आपण प्रिव्हियस लेक्चर्समध्ये सुद्धा हे बघितलेलं आहे. नाव ही ऑर्डर बघा. कार्बन शोज मोर आयोनायझेशन एन्थॅल्पी, देन सिलिकॉन, जर्मेनियम, टीन, then lead, and last one is tin. Tin shows very less ionization enthalpy. Then the electronegativity means what? Atom acquires the shared paired electrons towards itself is nothing but the electronegativity. आपण हे ऑलरेडी बघितलं आहे. The tendency of an atom to attract the shared paired electron towards itself. Now electronegativity is decreases from carbon to silicon, but the silicon to tin remains almost constant and the lead increases. बघा हा टेबल बघा. टेबलवरून आपल्याला कळत आहे कार्बन पासून सिलिकॉन पर्यंत ती डिक्रीज होणार आहे. अँड फ्रॉम सिलिकॉन टू टीन इट इज कॉन्स्टंट 1.8 1.8 1.8 अँड लेड इट इज 1.9. बघा ही इथे 1.9 आहे. ही थोडी इंक्रीज झाली. अँड वाय? इट इज बिकॉज ऑफ द शेल्डिंग इफेक्ट ऑर स्क्रीनिंग इफेक्टमुळे ते होतं असं. ओके. Now the carbon is most electronegative element in the group 14. Next one, there are some physical properties like melting point, boiling point and density. आपण बघूया. See, the all elements of group 14 are solid. Carbon is a non-metal while silicon and germanium are the metalloids. They show the metallic as well as non-metallic character. Tin and lead, these are the soft metals. Down the group, जसं आपण खाली जाऊ melting point and boiling point काय होत जातील? Decrease होत जातील. And the density is increases. The melting point in the increasing manner, in the decreasing manner. इथे melting point decreasing manner मध्ये बघा. decreasing format मध्ये इथे melting point दिलेली आहे. Carbon shows more melting point than silicon, germanium, tin and lead. Then see the boiling point in the decreasing manner. Carbon shows the more boiling point. Carbon ला जास्त बॉइलिंग पॉइंट आहे देन द जर्मेनियम, टीन, सिलिकॉन अँड लेड. देन द डेन्सिटी हियर डेन्सिटी इज increases from carbon to silicon, it is decreases. After germanium to tin, it is increases. See, so these are the physical properties. So therefore the density is in decreasing manner. Lead shows more density than tin, then germanium, then carbon and then silicon. Now important note, elements of group 14 higher melting point and boiling point than 13 because of the increases the nuclear charge, and that's why the nuclear charge increase होतो. So that's why the melting point and boiling points are increases. बघा हा important point आहे, लक्षात ठेवा. Now see the multiple choice question. Significant radioactive isotope of carbon. ऑलरेडी आपल्याला माहिती आहे की कार्बन 14 हा आइसोटोप खूप महत्त्वाचा आहे, which is very important. The electronegativity of silicon is 1.8 and then the electronegativity of germanium is ऑलरेडी आत्ताच आपण तो टेबल बघितला आहे, कॉन्स्टंट दॅट इज 1.8. केमिकल प्रॉपर्टीजमध्ये आपण ऑक्सिडेशन स्टेट बघणार आहोत. सी द ऑक्सिडेशन स्टेट +2 and +4 इज द कॉमन ऑक्सिडेशन स्टेट. व्हॅलन्स सेल कंटेन 4 इलेक्ट्रॉन्स. आता प्रत्येक व्हॅलन्स सेलमध्ये 4 इलेक्ट्रॉन्स आहेत. आपण इलेक्ट्रॉनिक कॉम्प्लिकेशन बघितलेलेच आहे. सो द ऑक्सिडेशन स्टेट +4 ही सर्वांची आहे. लोअर मेंबर शोज +2 ऑक्सिडेशन स्टेट. इट इज बिकॉज ऑफ इनर्ट पेअर इफेक्ट. ऑलरेडी वी डिस्कस द इनर्ट पेअर इफेक्ट. मीन्स जे लोअर मेंबर असतात, शेवटचे जे मेंबर आहेत फॅमिलीमधले, लेड ओके किंवा कार्बन मधल्या फॅमिलीमधले जे शेवटचे मेंबर आहेत टीन आणि लेड, ते इनर्ट पेअर इफेक्टमुळे +2 ऑक्सिडेशन स्टेट दाखवतात. इनर्ट पेअर इफेक्ट म्हणजे काय की एस ऑर्बिटलमधले जे इलेक्ट्रॉन्स असतात ते बॉन्डिंगमध्ये इन्व्हॉल्व होत नाही, त्याला इनर्ट पेअर इफेक्ट असं म्हणतो. लक्षात ठेवा. The tendency of an outer s orbital electrons to remain the paired and not take part in the bonding as we move down the group. So that is हे कशामुळे होतं? It is because of poor shielding effect. हेही लक्षात ठेवा. So carbon shows +4 -4 oxidation state. Silicon and germanium shows +4 oxidation state. Tin and lead shows stable +2 oxidation state. It is because of ही कशामुळे आहे, it is because of inert pair effect. हे कशामुळे आहे, tin आणि lead because of inert pair effect they show the +2 oxidation state. Due to the absence of d orbital, carbon cannot expand its covalency more than 4. Absence आहे, d orbital present नाही आहे, अवेलेबल नाही आहे कार्बनला, म्हणून तो 4 पेक्षा जास्त त्याची कोव्हॅलेन्सी वाढवू शकत नाही. See the table. In that table we look the metallic character also, color also and oxidation state also. Carbon is a non-metal, black color, +4 -4 oxidation state. Silicon is a metalloid, light brown color, +4 oxidation state. Germanium metalloid, grayish white color, +4 +2 oxidation state. Tin, which is metallic in nature, silvery white color and +4 and +2 oxidation state. Actually it shows +2 stable oxidation state. Lead, which is metallic in nature, color is silvery white and which shows more stable +4 oxidation state. This is because of inert pair effect. Okay, now see the MCQ. Carbon cannot expand its covalency or valency beyond 4 because of there is a absence of d orbital. Already आपण बघितलं, that is option number D. The element which shows +2 oxidation state, stable +2 oxidation state, lead, because of inert pair effect. Lower element of carbon family shows +2 oxidation state. Thank you.